formula. Okay? The formula that we're going to use, I'm going to teach it to you 2 different ways. And once we work through it the first way, the second way should make a little bit of sense to you. Okay? So when we talk about volume, okay, first of all, let's think very quickly. When we talk about something that is squared, okay, that means we're multiplying 2 numbers together, right? Length times width, or the area of something. Whenever we're doing a square, we're doing length times width, so we're multiplying 2 numbers. Okay? So we always end that with units squared, be it feet squared, inches squared. Okay? Anytime we talk about volume, we're no longer squared. Does anybody know what we call it when we're talking about volume? We're not squared, but we're using, Kirsten, you know? Cubed. Okay? So anytime that we talk about volume, we're talking about units cubed. So no longer are we using the little 2, now I'm using the little 3. Is it pertinent or important that I know that? Yes. Because if you don't put it, then you're telling me perimeter. If you put a 2, then you're telling me that's the area. 3 signifies or symbolizes that we're talking about the volume of something. Okay? When we talk about volume, we're dealing with 3D shapes. Okay? So, let me first show you. If you look across the top of your book, it's kind of giving you a visual image of how volume works. The formula that we're going to be using for volume, we're going to just use the letter V. Have you done volume before? Yeah. Volume equals, does anybody remember what it is? Ella? Length times width times height. Okay? So okay, so when we talk about volume, we're doing length times width times height. So we're multiplying 1, 2, 3 numbers together. Okay? Typically, they're going to give you a shape, and this one I'll just kind of work out and you can watch, and then we'll talk a little bit more about the ones in your book where it gives you the unit blocks or the unit cubes. Okay? So, we have a 3D figure, and they're going to tell us this is 3 inches, this is 5 inches, and it might be 7 inches long. Even though this looks like a perfect square, we're going to call it a rectangle. Okay? Whenever I'm looking at this shape, I have to give the length, the width, and the height. I have to basically assign them a number. Okay? I like to always do the height first because that's usually the easiest one to figure out. Sometimes a common mistake that we make, or we confuse what's the length and what's the width. Okay? It doesn't really matter, folks. As long as you understand that all you're doing is multiplying these 3 numbers together. Okay? So when we follow our formula, we're going to write volume, or V, equals length times width times height. Okay? I'm going to go ahead and tell you, for a future reason, out to the side of your shape, write your letters and assign them a number. Okay? So I'm going to say my length is 3. I'm going to say my width is 7. And my height is 5. Okay? I'm telling you to do this because when we find volume of your regular shapes, you have to be able to remember which number you used for the length, which one you used for the width, and which one you used for the height. Okay? So go ahead and get in the habit of writing that down where you're pulling those numbers off that shape and assigning them to a letter. Does that part make sense? Pretty easy, right? Okay. So all I'm going to do now is I'm going to fill this in. So my volume equals, my length is 3 times my width is 7 times my height is 5. Okay? Volume equals 3 times 7 is 21 times 5. Anybody know what 21 times 5 is? What's 20 times 5? 100. Well, 20 times 5 would be 100, and then 5 times 1 would be 5, so 105. Okay? What label do I need to put at the end of this figure? Not unit, not a U. I need to put inches cubed. Whoa. Inches cubed. Okay? The only reason I used a U up here is just to show units, because I wasn't naming a specific unit like inches or feet or meters or miles or anything like that. So that's why we refer to it just as a unit. Okay? Pretty easy, right?
Yeah.
Jimmy, please stop. Alright, I am not going to attempt to draw one of those that has all those little cubes in there, but I do want to show you the other way that you may see the formula. So, we may see the volume formula written like length times width times height, okay? And that's pretty easy to work with. Okay? We may also see volume written as base times the height. Okay? When they use the word base, basically all they're doing is going ahead and multiplying the length times the width and getting one number for it. Okay? So if I have a shape that looks like
Just like that other lesson, like when we tell you what it's called, like the area triangle.
no. Basically what we're doing is we're doing the surface area of the bottom, and then we're going to multiply that times the height, which takes me straight up through that entire figure. Okay? So whenever we look at this formula, what I have shaded here is the bottom, what this shape would be sitting on. Okay? We're going to call that the base. If I were to give this figure a length, a width, and a height, let's say this is 6 meters, this is 2 meters, and my width here is 4 meters. Okay? Whenever I'm looking at this shape, let's see if I can make more sense to this. Okay. What this formula right here is saying, this bottom formula, as I was telling you, all they did is they went ahead and multiplied the length times the width and put that into one number. So, if I was going to work this figure here with the base times height formula, the first thing I would have to do is find the area of my base down here. So this part that I have shaded in, the part that it's sitting on, the bottom, okay, that would be 6 long by, okay, if this side is 4, this side has to be 4, right? So 6 times 4 is, so my base is equal to 24. Okay, now if I'm going to use this formula here, volume equals base times height. Volume equals 24 times my height is 2.
48.
So my volume would be equal to 48. Okay? So there's 2 different ways that we can use this formula. The reason I'm showing you that is sometimes in their homework they don't even show you the figure, but they'll tell you I have a base of 16 feet and I have a height of 7 feet. And it might tell you to find the volume. What you have to understand about this is you have to understand if they're telling you the base, that means they've already done the length times the width. Okay? Basically, when they change it from V equals length times width times height, All they've done is they've already done some multiplication for you of the length times the width. They're going to call that the base. Then you just have to multiply times the height. Okay? So in this one here, if it told me to find the volume of a base that is 16 and a height that is 7, what would I do?
16 times 7.
I would just have to multiply 16 times 7. Okay? Got 12 feet cubed. Ready to try one?
Yeah.
All right. I'm going to give you it to you two different ways. Okay? If it's a base area, it has to be squared. Okay? Then when I multiply this times this, that's going to give me the cubic. Because then technically I'm multiplying those three together. Okay, you should be able to tell me what the volume of both of these figures equals if you understood today's lesson. Tell me both of them. I want to see both of them on your board. I can't see your top one at all. Okay? Here I would follow the formula of volume equals base area times height. So I would take volume equals my base, which is 14, times my height, which is 7. 7 times 14 is 98 meters cubed. Okay? Remember, when they're giving you the base area, all they did is already multiply the length times the width for you, Ben. Okay? When I'm doing the bottom down here, they did not give me the base. Could I figure the base out on my own? Yeah. 3 times 4 is 12. 12 times 10 is? Okay? Or I could follow the formula of volume equals length times width times height. L, W, H, 3, 2, and 10. Okay, so volume equals 3 times 2 times 10. 3 times 2 is? Oh, duh, because that's 4, not 2. 3 times 4 is? 12 times 10. Feet cubed. Okay, so that's just a quick one to prove to you, no matter if you do the base, the area of the base, times the height, or if you do length times width